So good afternoon,
Corey.
everybody. Thank you so much for joining us. It's wonderful to have so many of you joining us for lunch today. And I'd like to extend a very warm welcome to Bite-Sized Corrosion. For those of you who are joining us for the very first time, this is a platform where we share bite-sized nuggets of information related to corrosion in the hope that it will make things easier for you in your own experiences. Our session today is slightly different from our previous formats. Today, we're starting a short three-part series of conversations we've titled The Engineer's Casebook. And we're going to be drawing on the wealth of practical life experiences of several engineers to give us advice for our future challenges. In other words, they've already burnt their fingers, so let's save ourselves some of the pain. And today in the hot seat, we are welcoming Piet du Plessis and Neil Webb to share some useful pointers from their many years of collaboration about how cathodic protection can, quote, save the day. Now, before I get ahead of myself, let me introduce our guests. Neil Webb really needs no introduction. He's a very familiar face on Bite-Sized Corrosion and has cathodic protection experiences from the past 43 years or more. And they've provided excellent teaching moments to myself and many others. Our second guest is Mr. Piet du Plessis. And I've had the honor of working with Piet over several years. And in my mind, he really is Mr. Bulk Pipelines, always passionate to ensure that cathodic protection features on the pipelines with which he's involved. And I've always enjoyed his great grasp of all things related to bulk water pipelines. So a warm welcome, Piet. And instead of me reading a bio about you, perhaps you could briefly introduce yourself to us.
Thank you, Vanessa. I've started with, thanks for inviting me to this webinar. I've started with Department of Water Affairs in Namibia. My career moved down to Stellenbosch, worked for Geestein, Forsyth and Hubert, and then moved up to the Free State, Otto Langenegger and Partners, and then we merged with EVN to become Vegan Africa in 1999. And I sort of ended my career with Vegan after 32 years in Pretoria. I've retired at the end of last year, but I'm still working as I've started my own company, PD Water Consult. I was privileged to be involved from the start, from the Department of Water Affairs right through to the end in large diameter pipeline and especially steel pipelines, which is sort of a passion of mine. The one thing about steel pipelines, although they've got many challenges, and we will address one of the main challenges today, and that's corrosion. This is still the only pipe material that works for any pressure and any pipe diameter. All the other pipelines has got limitation, or materials got limitation with regard to diameter, available diameter and pressures, but the steel pipeline are available to all diameters and classes. Thanks, Vanessa.
Piet, I can see from the way your face lights up that you and steel pipelines just love each other hugely. Now, I was doing, in preparation for this, a little bit of delving into the history books. And I gathered that you, Piet and Neil, met in the early 1980s in the Free State, where you mentioned you worked with for Otto Langenegger and Co. Do you recall some of the details of your early meeting?
Yeah, that was one of the first steel pipelines I was involved in. I think we started design in 81 and the construction took place in 82, 83. And that was a 70 kilometer, 1.2 meter diameter steel pipeline from the Val River at Balkfontein near Bothaville up to a place called Kopialeen, but that was to supply water to Welkom, Virginia, and specifically all the gold mines that were very active at that stage in the Welkom, Virginia area. The only lining and coating really available was bitumen lining and bitumen coating. So the pipeline went through wet areas, clay areas, sandy areas, a lot of variation in the soil conditions. And not long after it was installed, we experienced a problem of the coating. And maybe it's a good time now for Neil, who was then consulted to tell us what exactly was the problem.
I had been involved through the small consulting company I was with at the time in providing a cathodic protection design service for GF&J, as you mentioned. We had just completed a pipeline south of the gold fields, and the client had decided that it wasn't worth either the effort or the expense of putting this apparently new system on that Bulkfontein pipeline, because there were a number of parallel pipelines that were already there, which had no real problems other than some problems with the lining. And so initially the pipeline was installed without cathodic protection, and they experienced a leak in one of the low-lying wet areas. And when we investigated it was a combination of a coating failure and the effects of what we call long cell action, where you get different soil conditions setting up corrosion cells along the pipeline. And this pipeline corroded within 6 months or so of being laid without the benefits of stray current interference, which we are very aware of in other parts of the country.
Isn't it interesting that the conditions were perfect to set up the case for cathodic protection so early in your career, Neil, and also in your experience, Piet? Neil, just a quick question for you. You said that you'd installed cathodic protection on the first pipeline, and that on this pipeline it was done as a retrofit. Were there any quick pros and cons between the two options, other than the fact that the second part did have a hole in it?
I think the main issue was with it being a retrofit was that the pipeline was not necessarily completely cathodic protection ready. So things like test points and bonding, and we had to cross bond to the existing pipelines to make sure we didn't have interference between the various systems. So that made the installation a bit more challenging than it would have been if it had been done as a new build operation.
Right, and the first pipeline that you were involved in the vicinity was cathodic protection from the get-go?
That's right, yes.
Okay, so that would have been easier. Piet, have you had any follow-up? I mean, I know that was just a few years ago, the 1980s. Have you kept up at all with the status of those original lines? Do you know their condition or how they're doing? Does the CP still work?
I have been involved with it was at that stage Goldfields water. Is now Sedibeng water. So it's Sedibeng water, and I was involved there up to a couple of years ago, and they've got a whole network of pipelines, and that specific pipelines, the Bulkfontein Kopialian, at that stage we haven't experienced any problems with regards to leaks, etc.
Well, that's quite encouraging, and I'm sure that also that experience of not putting on CP and then having to probably resulted in them putting cathodic protection onto the majority of their pipelines. Neil, would you know anything in that regard?
Well, actually, yes. What happened was that the client then decided to roll out cathodic protection on the rest of the network of lines around Welkom, Oudendaalsrus, Wakkerstroom, and so on. And it was such a big project that it actually led to a significant amount of collaboration in the cathodic protection industry, and the merging of some of the competitors in the industry into a bigger company. And that company is still going today.
Isn't that fascinating? And it's also so encouraging to hear that after a 40-year interval that a cathodic protection system has kept a pipeline still operational. Personally, I think it's going to be something that becomes increasingly important because we've got relatively good infrastructure, but it's aging, and we need to keep it operational for South Africa to be a success. And this is just one example, I think, that proves that it can be done. I think that it's something that we need to focus on and encourage our clients to think about, although, Piet, as you rightly alluded to, they don't always choose steel anymore as a pipe material of construction, but cathodic protection on steel pipelines does work. Neil, previously, just changing tack slightly, you mentioned to me in passing that you also in that sort of era installed cathodic protection on a pipeline for Magalies water, commenting that it had some specific challenges. I wonder if you'd like to elaborate on those at all.
These were pipelines that had been laid in the 60s, and they were installed with Viking Johnson couplings and in an area where there were no DC stray currents. And so no additional protection had been provided on these pipelines other than the line wrapping or coating that was put on the factory. And the client, Magalies, decided that they wanted to extend the life of these lines and decided to then retrofit cathodic protection. And we had an interesting problem, and I'll share a picture with you, that as a result of the pipeline not being continuous, we had corrosion across the couplings. And this photograph is of an epoxy-coated section of line. And if you look across there, you can see there is a distinct line where the seal of the Viking Johnson coupling was. And this section down here, which has been corroded, was adjacent to the coupling. And the interference currents had jumped ship, so to speak, in this case, jumped pipeline and gone through the ground around the coupling. And these were not railway currents. These were just long cell action from the ground conditions. So here we had a situation where the pipeline was 15 years old, but it was getting to the end of its operational life in terms of being leak-free. We're now, that was 1980s, so now we're 35 years later with cathodic protection applied in a retrofit, and those lines are still fine. It certainly does have a place.
It's interesting, both examples that you guys have raised, the Balkfontein-Kopje-Alleen pipeline that Piet started with and this pipeline, both of them were installed in areas where perhaps cathodic protection wasn't considered important. And yet in both instances, cathodic protection was required, which makes me start to think that maybe cathodic protection should be considered for any steel pipeline. I don't know if you have views on that, Piet.
Vanessa, thinking back, I cannot remember of a pipeline where cathodic protection was not actually necessary. Well, it's steel pipelines. All the pipelines that I've been involved with required CP protection.
Sorry, just jumping in there. Very early on in my career, I had I suppose you could almost call it a life-changing experience. I was involved in a pipeline where it was very short to start with. It was only 2 kilometers long. And it had been laid in very high resistivity conditions. And whoever had been involved had said, oh no, this is high resistivity, it's not corrosive, you don't need cathodic protection. By the time they came to commission the pipeline 2 years later, because it was attached to a dam that was under construction, it was short rising main from the dam. By the time they commissioned it, it was perforated due to interference currents. I think one of the biggest lessons is that stray currents in particular, interference currents or long cell action or whatever it is no respecter of resistivity. And even in apparently benign conditions, we still end up with challenges.
Yes, and of course, in addition to challenges with corrosion, there are also challenges just with cathodic protection. And I know that Piet, looking back at all the pipelines, even newer pipeline projects, I know that you're concerned with some of the challenges of cathodic protection from a pipeline engineer perspective, as opposed to from our side being from a corrosion perspective. Any challenges that you have found related to pipelines and obviously their corrosion that keep you concerned about trying to mitigate the corrosion?
Pipelines are normally a very high cost component as part of the scheme. Cathodic protection is relatively to the cost of a pipeline or to the cost of a bulk water scheme is small cost. So it's worthwhile putting cathodic protection on when required, cost-wise. But as mentioned in the beginning, everything has got challenges, especially steel pipeline, and the steel pipeline challenges is corrosion. And we're talking now about corrosion on the outside, and cathodic protection can deal with it, and good coatings and good quality control of coatings during manufacturing and installation. But we've experienced many problems with impressed current cathodic protection system for the past couple of years with regards to, impressed current is electrical. There are electrical components. There's a transformer from Eskom that you require, and then there's a transformer rectifier unit that you require, and there are ground beds with electrical cables, etc. So the clients have experienced many problems with theft and vandalism on impressed current systems, which is really a concern and a problem. And you know, I've discussed this many years ago already with Neil, and I know there is development in that direction. I think it's a good time for Neil now to address the consultants and the clients' concerns with regard to theft and vandalism and maintenance on impressed current systems.
Neil, your comments.
Yeah, Piet, you know, prompted by what you've mentioned, and with a lot of your prodding, we've looked at moving. If I can, we had a talk a long time ago called "Sacrificial Anodes: Back to the Future," and for many years, sacrificial anodes were used for cathodic protection, and then they fell away. I think particularly with the stray current issues, as coatings have improved over the years, and polyethylene coatings, epoxy coatings, polyurethane coatings, and so on, have reduced the current requirements necessary for cathodic protection. So the practicality of using sacrificial anodes has become more and more prevalent. And in fact, the last couple of major pipelines that we've been involved with the design of, we have actually now opted for sacrificial anode systems in place of impressed current systems in order to get away from this issue of having this highly desirable recyclable material called copper in the ground. And so sacrificial anode systems are being installed based on zinc, which gives us a much longer life than the magnesium systems used to give us. And we can now install systems with easily a 30-year design life. And in 30 years' time, yes, you've got to go along and replace the anodes, but then at that stage, your pipeline is still good to go, and you start again from the beginning. And provided that maintenance is done effectively, you can get the life. There's a huge opportunity for research, though, in terms of the use of sacrificial anodes in stray current areas, which is certainly a challenge.
Well, and of course, in 30 years' time, who knows what might have been developed or imagined that we can't imagine today in terms of protection. Piet, you mentioned quality control of coatings, and I think we're all very aware that, particularly in our country, quality control is something we really need to keep our eyes on. We can do it right, but very often we don't. Obviously, we've focused our challenges today on external corrosion, but I know something else that's quite dear to your heart, Piet, is what about the inside of a pipe? Do you want to briefly raise any issues on the corrosion of pipes there?
Thanks, Vanessa. Just one thing where you really still need impressed current system where there's stray current, etc. One must, where possible, there is, if you can place your transformers and your transformer rectifier units inside pump station areas where it's safe, and that is an option, but it's not always possible. So that you get pipelines where you can do that, and that solves that theft and vandalism problem.
Yeah.
With cathodic protection, good coatings, good quality control, the coating, I think, can be sorted out, but we still experience many problems on lining. Okay, many years ago, the pipeline that we mentioned 30, 40 years ago, the lining was always really the only lining material available at that stage was bitumen, but nowadays we've got better linings, epoxy and cement water line. Now, cement water lining, in my opinion, is a very good lining, but it is limited. The quality of the water, it's dependent on the quality of water. Soft water will leach out the lime, etc. So and also on diameter. The feeling is that up to 1.2 meter, you can still line in a factory and transport without too many cracks, etc. But for the lining that's really applicable to all diameters and all situations suitable is epoxy. But we are experiencing problems with, especially on-site application, repair of epoxy linings where it has been damaged, and the application of linings to repair your joints, site joint lining repairs. We need for epoxy very good grit blasting, preparation of the surface, and it's inside pipelines. If it's a meter diameter, it's fine. Smaller pipelines, people might go in grit blasting. So repairs on epoxy lining, in my opinion, there's challenges, and I think it needs more investigation and research. So, but that's, as you said, that's maybe a subject for another.
Yes, well, I do think that there's a lot to talk about with internal linings. I know you've done a lot of research and have a lot of ideas on cement mortar lining. Looking at the clock, I'm not sure that we really have time to do that justice today, but maybe we can invite you back to talk with us next year in a casebook specifically focused on internal linings. I think that would be very interesting. I know that there are other groups in the country as well who are looking at internal linings and where we can use them. Just before we leave corrosion and cathodic protection, Neil, a question has come in for you asking what practical lifetime do you consider reliable for the design of both zinc and magnesium anode cathodic protection systems?
Magnesium systems, I tend to work on a practical life of 12 to 15 years. And the reason for limiting it to that value is that the only way you can extend the life of a sacrificial system is to put more metal in the ground. As you put more metal in the ground, you reduce the current density on the anode surface. And with magnesium in particular, if you reduce the current density on the anode, you increase the self-corrosion of the anode. So an anode goes from being 50% efficient, which is about the maximum you get out of magnesium under optimum conditions, and it can drop down to as little as 10%, the actual efficiency in terms of converting the magnesium into useful energy. So you cannot just throw more magnesium in the ground in order to get longer life. Zinc does not have the same issue, and it maintains its operating characteristics even at low current densities. And so you can easily design for 30 years of life and possibly longer. We don't have case histories to prove that on the onshore, but we do offshore. And we find that sacrificial systems on offshore structures, although they are primarily aluminium, some of them are zinc, and we're finding that the zinc systems certainly last and are a lot more long-lived. As a matter of interest, in Libya, maybe I can't remember how many years ago, there was a pipeline called the Great Man-Made River Project, which was a 3-meter diameter pre-stressed concrete pipeline through the desert. And that was protected with zinc sacrificial anodes.
With the zinc systems having a life of 30 years, that's longer than when I started in the industry. We were designing cathodic protection systems for it all. Neil and Piet, there's been another question that's come in regarding the theft and sabotage of cathodic protection. The Kwesa pipeline was completely destroyed within 2 years. And currently the 60-kilometer, 1400 diameter pipe has got no protection. All the bunkers have been stripped completely bare. Any comments on what we could propose as a possible solution and fixing the challenge? Put some zinc in the ground.
Yeah, one can retrofit zinc anodes connected directly to the pipe. You know, if the valve chambers are stripped out, it's the monitoring that's gone. The problem is the rectifiers. If the rectifiers have been stripped out,
then there's no CP.
Then there's no CP. So you could retrofit zinc. The other possibility is to do what they did on the Kusiri pipeline, is they built concrete blockhouses, which were virtually impregnable. The first ones didn't work very well because they forgot that little people can get through ventilator holes, and they did. But that then got rectified, and those are made out of, they're literally bomb shelters. And as far as I know, they have survived. One of the reasons they survived is that the Eskom high voltage, medium voltage supply was taken directly into the rectifier building so that there was no pole transformer to steel.
I think that might also be a way is to look at how we can get the grid power into the rectifier units without too many in-between stations. I'm looking at the time, and I think we need to start wrapping up. As we do close out our discussion today on the importance of cathodic protection on steel pipelines, Piet, I wondered if you've got any final comments or questions that you might want to just raise in closing to keep the conversation flowing into the future.
Yeah, basically two. The one must remember that cathodic protection is only required to protect your pipe where the coating is damaged. So if you can decrease coating damage, limit it to the absolute minimum, and increase your quality control, it's still good to have the CP system to cover the defects that you couldn't repair. But then the possibility to get leaks, etc., on your pipeline reduces significantly. So that's the main thing. Make sure that your primary cathodic protection system, which is your coating, has as few as possible defects during installation process by good quality.
That's a very valid point. Thank you, Piet.
Okay, and then secondly, Neil, a question to you. Many years ago, when we had the bitumen coatings, which was basically all coating available, and I'm talking about 30 plus years ago, we never worried about high voltage power lines in the vicinity close to the pipeline. Recent years, we always, have a problem with AC mitigation. We must cater for AC mitigation. Can you explain to us why suddenly now we have this AC mitigation problem on steel pipelines?
Sure, Piet. Yeah, that's a subject all on its own. Essentially, because the pipeline coatings have improved so much from an electrical resistance point of view. So effectively, we now have very well electrically insulated pipelines. Essentially, they've become oversized cables, insulated cables in the ground. And with this improvement in insulation, the inductance from the overhead power lines has increased. The bitumen coatings were essentially what we would call lossy coatings. So any AC that was induced was just dissipated to earth. Now it's insulated from earth. And so we are seeing these high AC voltages on the lines, which represent both a corrosion hazard and an electrical shock hazard. So we've improved the situation from a cathodic protection point of view, but actually made it a lot worse in terms of AC interference.
In fact, Piet, your question is very timely. And this is a wonderful opportunity to just tell everyone that, in fact, next week we're discussing this very topic, AC mitigation of pipelines. Craig Werter will be with us to open the discussion. I'd love you to welcome us to continue this bite-sized corrosion conversation on AC. Piet, Neil, thank you both so much for spending time with us this lunchtime. I think it's been a good discussion. I think sometimes they start more questions than they answer, and that's also not a bad thing. I've really appreciated the opportunity to have both of you to chat with, and I do hope that we can have other conversations in the future.